Hello people, welcome back, and today we're going to be looking at structure and bonding, which is part of your paper 1 chemistry. So we're going to be looking at ionic bonding, covalent bonding, and metallic bonding. We're just going to do a quick overview with the AQA Spec. Okay, so let's jump into it.
It's a nightmare. Activate.
Right, so now we're going to be looking at structure and bonding and the properties of matter. And AQA Spec is 4.2, and in the Carbudo, this is chapter 3, okay? You got three types of bonding. You got ionic, which is between a metal and a non-metal. You have covalent, which is between two non-metals, and then we have metallic, which is just between metals. Okay. Now you are gonna be able to, should be able to explain in bonds in terms of bonding and electron sharing or transfer, how is it that bonding works? Okay, so that's one of the things you want to focus, and that might very well be a 6-mark question. Okay, now when we scroll down here, we're looking at ionic bonding. Ionic bonding is basically a metal atom giving away an electron to become stable, but in the process it becomes positively charged because it got rid of a negative charge. Okay, and then you have a non-metal which gains electrons in order to become stable, and because it gains something negative, it becomes a negative ion. Okay, so we have sodium, which is the metal here. It gives away 1 electron and becomes +1, and you got chlorine, which is a non-metal. It gains 1 electron and it becomes -1, and then the electrostatic attraction between them gets them together. Okay, and then you have an ionic bond being formed. That essentially is that. Okay, now you gotta take in mind that you need to be able to read the periodic table and know what kind of ions these atoms are going to turn into. Right, so when we go into ionic compounds, this is what we call a giant lattice. Okay, so if you have here salt and chlorine and they make an ionic bond, you have sodium chloride. So over here, if we can think about this positive circle here, this positive atom being sodium and the negative one being the chlorine, these two here are made a sodium chloride molecule. But because all of these molecules are slightly attracted to each other, because this chlorine from this other molecule will be slightly attracted to this positive will be slightly attracted to that negative, right? So they all cluster together, making it very, very difficult to separate them. And then when you have a couple million molecules joining together, you end up with a giant lattice. Okay, for instance, sodium chloride is your normal table salt, and in a grain of salt, one little tiny grain of salt, you have a couple million molecules joining up together in a giant lattice. Okay, this is also a giant lattice, but this is called the stick and ball diagram. Okay, and you might be asked in the exam, how is it that giant lattice are so difficult to separate? And you would say that because they are all attracted to each other, they are maintaining this cluster form, and it's very difficult to separate them. Okay, they might ask you about the limitations of the ball and stick diagram, and you basically want to say that bonds don't really look like sticks and the atoms don't really look like that, and that's why it's just a representation on how they work. Okay, those are some of the 2 things that you might find in there. Okay, now it says here, deduce compounds, ions, diagram structure for one specific form, describe limitations of dot and dot. There we go. This is what I was talking to you about. Describe the limitations of using the dot and cross diagrams or the ball and stick diagram. Okay, 3-dimensional shapes as well, and work out the empirical formula for compounds. So if they were to give you a diagram, you should be able to write down what the actual formula for that would be. Okay, if they give you a diagram with an O atom and 2 hydrogens, you will know that that's H2O, and you have to write down the formula. The formula for this molecule is H2O. Okay, it's something simple like that. Before we move into covalent bonding, one thing that they will ask you, for instance, is this here. Where is it? Here. To explain how the chemical bonding happens. So in terms of ionic bonding, if we look at this, if this was a 4-mark question, you would say sodium is a metal, gives away 1 electron, that is 1 mark. Chlorine is a non-metal, is going to gain 1 electron, that is 2 marks. Sodium becomes a positive ion, called a cation, that's 3 marks. Chlorine becomes a negative ion called an anion, that is 4 marks. And if you say that they join together with electrostatic attraction, that's going to give you the 5 marks. Okay, that will be your 5-mark question right there. Now when we're looking at covalent bonding over here, it says that This is the bonding that happens between a non-metal and a non-metal as well, okay? These are two non-metals joining together. They don't turn into positive or negative because they are actually sharing the electrons, okay? So it says some of the atoms pair electrons, covalent bonding. These bonds are very strong, so that's something you want to remember, because when you're talking about simple structures, they'll ask you why is it that simple structure molecules are very easy to turn into gases and very easy to change into different states, okay? So covalent bonded substance consists of very small molecules. Students should be able to recognize common substances that consist of small molecules in the chemical formula. Some covalent bonded structure very large molecules such as polymers. So you got simple structures like this one here, NH3. You have water, carbon dioxide, oxygen gas, hydrogen gas. Those are very, very tiny. Those are simple molecules because they only have a couple atoms, okay? When you're looking at something like polymers, you're going to be looking at quite a few atoms. You got something like giant structures like diamond, graphite. You're looking at massive amounts of atoms joining together, looking into the millions, okay? So those would be giant covalent structures because there's millions of atoms joining together to that form covalent bonds between them. And then the simple ones would be something small like this, okay? Now in your test, you might be given you might be given this diagram here, and they will ask you to write in where the dots and X's go, okay? So the first thing you want to know is that nitrogen is in group 5, so it should have 5 electrons. Hydrogen is in group 1, so they should only have 1 electron. So this hydrogen here is sharing his electron, that one there as well, and that one there as well. Hydrogen's only got 1, okay? And that little dot is the hydrogen's electron. Now the X's are the electrons from nitrogen, so you got 1, 2, 3, 4, and 5. So this here is gonna cost you probably 2 marks, okay? You're gonna need to make sure that you understand what group these elements are, and therefore you will know how many electrons they have in an outer shell, because they will only show you the outermost shell, okay? You wouldn't worry too much about polymers unless you're doing a higher, which basically means that a monomer is something like ethene here, and a polyethene will be loads of these molecules just joining together one next to each other, okay? Then we say draw, and students should be able to draw and dot and cross diagram of hydrogen, chlorine, oxygen, nitrogen, hydrogen chloride, water, ammonia, and methane. Okay, you want to focus on this. They will give you that type of diagram for you to fill in the X and the dots. Okay, so over here is what we said, that very small simple molecules like water and oxygen and carbon dioxide, because they only have a few atoms joining together, right? That makes them simple molecules. The majority of them will be gases at room temperature, and they're very easily to break away from each other, not like the clusters of the ionic bonding, ionic lattices, because they have very weak intermolecular forces keeping them joining together, okay? Unlike the ionic ones that are slightly attracted to each other, making them stronger to be together, okay? Then describe the limitations of a ball and stick diagram, the same thing that you did before. Atoms don't really look like that, okay? So that's something you want to explain, and that's the limitations of it. And it's not everything always in 2D, okay? The molecules are in 3D. Deduce molecule formula. So if I were there to give you this here, what will be the formula? The formula will be NH3, okay? And all of these ones are they're all the same, it's just different ways of representing NH3, okay? Then we go to metallic bonding. Metallic bonding consists of giant structure atoms arranged in regular patterns, okay? So everything in metals will be arranged in regular patterns like that. The electrons in the outermost shell are delocalized. That means that they don't have a specific location. It's not like the ionic bonding and the covalent bonding that you're likely to find them in a specific place, okay? You will find them in very different places all the time, and because they're delocalized and they keep on moving, we say that they have free electrons, or a sea or delocalized electrons, and therefore metallic bonding or metals more like are able to transfer electricity